Means and standard errors. Here I'd like to show you how to graph means and standard errors of the mean from your SPV files given by SPSS. So in this case, we are plotting a graph showing good and bad beat perceivers in walking with different cue types. So low groove music, high groove music, and metronome at 3 different tempos: slower, preferred, and faster than their usual walking cadence. So if you click here, you see the table given to you. So you don't need these 2 columns, you only need these 2 columns, but because SPSS is like that, you have to copy the whole thing. So if you hit copy, like I did just then, what you can do is, if you open Graphpad, this is how it will look like. It will ask you to select what kind of table you like to draw. So in this case, you say, I just want to draw the table first, don't plot the graph for me yet. And I also want to plot error values already calculated elsewhere. So I'm just going to hit create, and then I'm just going to paste the whole table here. Now you can see this is the exact same table. Remembering that the last 2 columns are simply 95% confidence intervals, which we are not interested in drawing here for now. But if you want, you can. So here I'd like to put everything from the good beat perceivers into one column, so column A. So I'm just going to cut that and paste that through. And I like to do the same thing for good beat perceivers for column B. Oops. And copy everything into the first row. So I'm just going to delete the rows so that everything shifts upwards. And these 1, 2, 3 values simply correspond to the different conditions that you ask SPSS to order it in. So here is the first cue type, which was low groove music, the second was high groove music, the third was metronome, and so on. Same thing for the good beat perceivers. So you can type in those values there. Now the third factor here was tempo. So if it's 1, 1, then it's low groove music and slower. 1, 2 is low groove music, preferred tempo. 1, 3 is low groove music, faster than preferred tempo. So we're just going to type those values in. So low groove, slow, or let's just use short form. And the same thing for high groove music. So and then again for metronome. And remembering the A column, the first column is bad beat perceivers, and second column is good beat perceivers. The reason why it appears like that is because I've typed it in before, so Graphpad guesses that you want to type that and then autofills it for you. Now you can go ahead and create a new file, a new graph, so new graph of existing data, and it will pop up. Sorry, it takes a little while because the computer isn't very used to this having many programs open at the same time. So if you find that Graphpad hangs, you can simply hit escape to get it to wake up again. The good thing about Graphpad is it will also save every 2 minutes. What you can do is you can choose different types of graphs. So there's many different types of graphs you can plot with Graphpad. One thing that's useful for repeated measure designs is this before-after graph. That can be very useful for individual data. If you want to see how individual data act in different conditions, that's very useful. But for this, we're just going to draw a grouped bar graph. So we wanted to plot the means with the standard errors of the means, and we want to plot all data sets. You can choose to plot only selected data sets, but here we're just plotting everything. Okay, so now the graphs are by default quite unattractive for some reason. So you can double click on the bar graph itself and change. So if you want to remove these unattractive patterns all at once, so you click this button, all, change format of all datasets at once and remove the pattern like that. Hit OK, and all of them are clear now. With most graphing programs, they will automatically give you a range from 0 to whatever value they think is most sensible, but often this is not very sensible. You would like to really showcase any differences between conditions. Therefore, you should try to look for the smallest value, plus minus the standard error bars. So in this case, I think it would be appropriate to go 0.85 to about 1, and that will really show what differences there are. So going back to the bar graphs, we have good and bad beat perceivers now both as white bars, and so we probably we can call the bad beat perceivers white bars and the good beat perceivers gray bars. So here, that's what I've done here. I've just been filling the gray bars for the good beat perceivers. I also want the error bars to be both directions, not just above the mean values. So I'm just going to hit all and change the error bar directions to both directions, and that's done that automatically. So now I would like to label my axis, and just label your axis by simply clicking Y title, and then it will automatically come up with whatever you've previously done. So this is sometimes very helpful. The formatting is also the formatting you like. I like to have italicized graphs, and the x-axis here is tempo, condition by tempo. So for Q type by tempo, Q type by tempo, and again you can label your graphs by just typing in. So here we have normalized, we call it slide length, and you can also just drag drop your legends to be slightly further away so they're more legible. So I might go and exaggerate this even more. You don't want your tips of your graphs to be clipped because you reduce the range as well. So what's that one? 1.05.